This is a mini lesson for combining like terms that involves simplifying within terms. So the Do Now has 3 problems that review skills from 6th and 7th grade and then our new skills with 8th grade. So if you recall, 2x plus 3x, those are like terms, and so we get 5x. We're saying how many x's do we have? They're like terms because they have the same variable to the same exponent, in this case x to the first and x to the first. So we add the coefficients and we keep the exponents. Similarly, in number 2, 2x squared plus 3x squared, since they're both x squared, we would have 5x squareds, so 5x squared. And a lot of times some strategies that you would use in other grades was either to use different underlines or colors or different shapes to box in your like terms. Number 3 is an 8th grade skill. This is all one term, and I know that because I see that it's a multiplication problem and terms are separated by plus or minus. So in this case, we have 2x squared times 3x squared. So you could think of it as 2 times x times 3 times x times x. 2 times 3 is 6, and there are 4 factors of x. We have x to the 4th. You can also think of the x squared times x squared as keep the base and add the exponents together because we're multiplying like bases. So now we'll see more of the type of problems that we are going to see. And so these are longer strings of addition and subtraction where we need to combine like terms, but we also need to first simplify within a term in a lot of cases. So in the first problem, I see 1, 2, 3, 4, 5, 6 different terms here. And I know that because they're separated by plus and minus signs. But I'm actually going to go back and I'm going to mark different like terms in, I'll use the same color since I'm in Notability. So I see I have 4x cubed plus x cubed. Well, that's really a 1x cubed. So that gives me 5x cubed. Then I'll look for another set of like terms. I see negative 2x squared and I see positive 2x squared. And careful of this one here, I do see an x squared, but it's an x squared y, which means it is not a like term with my x squareds. In this case, since these are opposites, they cancel out. And then I have 2 terms left, neither of which have any like terms with them. So I will just have minus 7 and plus x squared y. Sometimes people may care about the order of this. I usually put it in ascending or descending order from the biggest to the smallest exponent if they were all terms with x. In this case, I'd probably leave it or move the negative 7 to the end. In the next problem, I again see separate terms here, so I could imagine separating them by these plus and minus signs. And so within each term, we first want to simplify if possible. So the first term, I need to apply the exponent in first, so I have 4 times 4x to the 6th, which is 16x to the 6th. My next term is already simplified. My next term is a multiplication problem, so I still have the minus here, and 3 times 10 is 30. X to the 4th times x to the 2nd is x to the 6th. And then x to the 0 is 1, so while that wouldn't affect our problem in a multiplication problem, we will have a plus 1 in this problem. So now I'll look for my like terms. So I see a pair of like terms with x to the 6th, and then I see an x squared, and then I see an x to the 1st. And in this case, I'm using different underlines to show you a different strategy here rather than different colors. This is a better strategy if you're working in pencil. So I have 16x to the 6th minus 30x to the 6th gives me negative 14x to the 6th. I'm just combining my coefficients there. Then minus 5x squared plus 1. And in this case, this is what I was talking about. I would always put my term with x to the 6th, then x to the 5th, 4th, 3rd, 2nd, 1st, and then just my constant. So I'll box in that answer, can box in this answer. And I have one more problem here, and again, I have separate terms, and so I'm going to simplify each of those terms separately. So the first one, I'll do a little bit of mental math. So inside my parentheses, I see 8 x's, and so I have 5x to the 8th squared. That gives me 25x to the 16th when I apply in this exponent, 5 squared and x to the 8th squared. Then in the next problem, it's a fraction bar. 6 over 2 gives me a 3 in the numerator, and x to the 25th over x to the 12th gives me an x to the 13th in the numerator when I subtract those exponents to figure out how many x's are left. Minus 6. And then I have a 2 to the 4th. 2 to the 4th is 16. x to the fourth is x to the 16th. We end up multiplying those exponents, and my last two terms are already as simplified as they can be. So let's look across for our like terms. So I'll show one more strategy. Some people like to use different shapes, and don't forget when you box in your like terms to keep the sign with it. So I see some x to the 16ths, I see some x to the 13ths, and then I see two remaining terms that don't have any like terms. So 25 x to the 16th minus 16 x to the 16th is 9 x to the 16th. 3x to the 13th minus 3x to the 13th, those end up canceling out. Then I have my plus 9x to the 8th and minus 6. And so if I was looking for some key ideas, I might think about simplifying within each term first. I might think about remembering that when we combine like terms, we do not change the exponent. Terms are separated by plus or minus, things like that. Thanks for watching.